All right, now that you know how to make a line of best fit, now we're going to actually use the line of best fit. So the whole point in having a line of best fit is to use it to make some predictions. Now, notice I'm saying it's a prediction. It is not going to be exact. It isn't a for sure thing. This is just approximately what could happen. So just a couple of things to review here. This scatter plot right here is showing a pretty strong negative relationship. It is going in a downward direction. That means it's negative. It's fairly strong because it's pretty close to this line of best fit. So that means any predictions we make are going to be fairly accurate. Okay. The statement that we could say is as the weight of the car increases, the average miles per gallon decreases. That's what this is showing. And again, it's linear because it has a line of best fit. So any of these are going to be linear because we're using a line of best fit. All right, so a couple of common mistakes here is that any relationship is going to help us make good predictions. So if you look at, this is a little off here. I'm just going to push this over here just a little bit. If you look at a couple of these graphs here, you'll notice that this data is very close to this line of best fit. I'm not loving this line of best fit, by the way, because it is not extending all the way through the line or through the graph. And that graph, we could probably zoom in on a little bit. It could make it look a little bit better so we can make better today or here. But anyway, so the second one you'll notice is pretty scattered. So this is probably not going to make really good predictions. You can make a prediction, but it's not going to have as strong of a prediction as this one over here. All right, so taking a look at some data here, I'm going to kind of zoom out a little bit just because it's kind of hard to see what's happening. Okay, so here is our weight of our car and the average miles per gallon again. So we're going to make a prediction. What kind of gas mileage would a car that weighs 2,500 pounds get? So notice we have this whole 2,500 area of the weight of the car highlighted. Notice our data is scattered between 20 miles per gallon and 35 miles per gallon. Okay, you'll notice a majority of the data is in this green section from 25 to 30. So we're making some predictions even right now without a line of best fit. So this would be our better prediction, 25 to 30, just because that's where the data seems to be clumping, but it does range from about 20 to 35. So we know it's going to be somewhere in there, okay? But now if we add a line of best fit, we can get even more specific. And I'm going to show you this part first and ignore that equation for now. But if you go to 25,000 or 2,500, sorry, that would be a really heavy car, and go over, you can see that our line of best fit that's now in there can help us predict that it's going to be about 27, 28 miles per gallon. All right, and we can do that for any of these weights. Okay, so that's how you would use that graph. Now, what we're going to get to in the next video after this is that we're going to figure out an equation for this line of best fit. And this is how you use the equation to make your prediction. So if this is the equation for this line of best fit right here, and we knew the weight of the car was 2,500, notice the weight is along the x-axis. So in this equation, we plug in 2,500 for x, and then we solve, and we find that it's 27.8. All right, so that's how you can use the equation if you have it, or once you learn how to create it or get it. Or you can just use that line. Here's another situation if we look at it kind of in the opposite direction here. If a car is advertised as getting 18 miles per gallon, what would you predict the car's weight to be? So now this time the miles per gallon is along that y-axis, so we're highlighting where the 18 is approximately. And you'll notice that the weight ranges, or the data ranges, from about 3,000 to about 4,500. Now notice the clustering is in this green part. So between 3,500 and 4,000 pounds. Okay, so that's without using our line of best fit. We can already make kind of a prediction. But if we get an actual line of best fit here, we can use the line of best fit to make an even better prediction. So we find 18, go over to the line and down. We'll find that it's somewhere, and again, it's a range, but somewhere between 3,600, 3,800 pounds. Okay. Now again, if we have that equation, we can make a prediction as well. But now notice this 18 miles per gallon is a Y value. So we would use the equation a little differently. We would plug in that 18 for Y, and we would solve the equation from there. Subtract the 48.8 from both sides, and then divide by that negative 0.0084, and we find it's about 3,677 pounds. Or sorry, 3,667 pounds. So that's how you use your line of best fit, or the equation, to come up with a prediction. So now we're going to practice that. So what I want you to do is to predict, using this line of best fit, what weight can you predict the baby will be at 9 months old? So go ahead and answer that question now. So you should have been able to use that line of best fit to come up with this prediction. You would go to 9 along the x-axis and go up and over to that line and over to the y-axis, and we would find that it's about 17 pounds. Okay, let's go ahead and do another one. At what age can you predict the baby to weigh 12 pounds? Go ahead and answer that question now. All right, to get that answer, we would do the opposite. We would find the 12 pounds along the y-axis, go over to our line of best fit, and go down, and we would find that approximately 3 months old. Notice these predictions should be pretty good because these points are all very close to our line of best fit, so we should be getting fairly good predictions. All right, next one. If a student wants to get at least 65%, what's the least amount of time the student should expect to study? So use your line of best fit to predict that. All right, here's how we can use that line of best fit. We find 65, between 60 and 70. On the y-axis, go over to our line of best fit and go straight down, and we find that it's somewhere between 15 and 20 minutes, like 16 minutes or so. But I'm hoping you want more than a 65%, so you would study longer, right? All right, next one. If a student misses 10 days of school, what grade can the student predict they will earn? Go ahead and answer that question now. All right, you should have used your graph this way. 10 days absent, go up to our line of best fit, would extend down here. And this is why we extend our line, so we can make these predictions. And go over, and it's just under 40%, so about 38%. All right, here's another. If a student studies 15 minutes, what percent can the student predict to get? All right, so if we are at 15 minutes, we should be at about a 65%. And notice this is a mistake that a lot of people make, and I've been talking about this a lot along the way. Remember, this is a prediction. It is not exact. It's an estimate. So it should be somewhere between this range here because our data is within that range. All right, so quick quiz here. Which graph is going to give us a better prediction? Graph A with our quiz scores, or graph B with our test. Go ahead and answer now. All right, you should be able to pick graph A, this first graph, because our data is a lot closer to our line of best fit. Look at the range here in our other graph to our line of best fit. There's a big range in data, whereas our data is very clumped and close to that line of best fit. So this would give us a better prediction. All right, that's it. You should have an idea of how to use a line of best fit to make some predictions now.